Okay, hello everybody. So we're beginning a new section, which is really a continuation of the previous section, but we're going to derive and use these, what we call the double and half angle formulas in trigonometry. And again, this is where we're at the point where, students tend to kind of hate trigonometry at this point because there are so many formulas. I really want you to show where these come from and how to use them, rather than memorizing all of these. Obviously, with an online class, you're going to have the formula sheet right in front of you anyway, but want to see what they are. So we're really going to be getting formulas for, let's just say, given an angle theta, we'd like to find what the sine, cosine, tangent of twice that angle is and what half that angle is. So we have a total of, about, 10, 11 formulas here. And rather than go through all of these, I just want to show you how we derive them really quickly. And actually, they're all derived. There's no geometry involved at all. They're all coming from the sum and difference formulas that we had in the previous section. Okay, and remember what that is. We had, the sine of a plus b is the sine of a cosine of b plus cosine A sine of b. And we have the cosine of A plus b is the cosine of A, cosine of b, minus sine A, sine b. Okay, and it turns out these are the only formulas we need to derive everything. Okay, so the question is, why is this true? Well, the easiest way to do this is to, if we want to find what the sine of twice an angle, just let A equals B in this case, right? So, why these formulas are true, so the sine of 2 theta is the sine of theta plus theta, so this would be, according to the previous two formulas, we have sine theta, cosine theta, sine theta. These are obviously, these two terms are equal. So this is just 2 sine theta, cosine theta. For cosine of 2 theta, this is cosine of theta plus theta. So this is cosine theta minus sine theta, sine theta. And this is going to be cosine squared of theta minus sine squared of theta. Okay. Now, but however, we can have a couple other forms of this. We know that we can replace cosine squared with 1 minus sine squared. And then if we distribute everything in collect like terms, we get 1 minus 2 sine squared of theta. Or we can also keep the cosine squared and replace this sine squared with 1 minus cosine squared, distribute the minus sign, and then we get 2 cosine squared of theta minus 1. Okay? And then once we do that, we can, we also have a formula for the tangent of the sum of 2 angles, which I did not write down, but we can just directly use that, and we get tangent theta plus tangent theta over 1 minus tangent theta, which of course can be simplified to 2 tangent theta divided by 1 minus tangent squared of theta. Okay, so that's one set of those are the double angle formulas. Okay, and we have next, we have, let's go to the next one. Let's first get a formula for the square of cosine and the square of sine. From the first set of formulas here, we have cosine of 2 theta is 1 minus cosine squared theta minus 1. And then we do a little bit of algebra. We add 1 to both sides, divide by 2, and we get cosine squared of theta is 1 plus cosine of 2 theta. And then similarly, we also know that cosine of 2 theta is 1 minus 2 sine squared theta. We can multiply everything by -1, and then add 1 to both sides, divide by 2, and that's how we get this formula right here. Okay. All right. Well, that's great. That'll be good. That when those of you who take Calculus 2, these formulas will be very, very helpful. Okay. For the rest of you in doing in your life, maybe not so much beyond this course. But Anyway, now if we do a little substitution, and if we want, let's say we wanted to find sine squared of theta over 2. Well, theta over 2 is still a number, and we know that the according to this, if we take the sine squared of an angle, it's going to be 1 minus cosine of 2 times whatever that angle is divided by 2. So we're replacing theta with theta divided by 2, and then 2 times theta over 2 is just theta. So that's why sine squared of theta over 2 is 1 minus cosine of theta over 2. And then if we want to, we can take the square root of both sides. We get plus or minus the square root of 1 minus cosine of theta divided by 2. Now, we don't know what quadrant theta is, and we don't know what the quadrant theta over 2 is. So that's why we have a plus or minus. Obviously, we're not saying both of these values can work. It's either going to be plus or minus depending on what quadrant theta over 2 is in. And then we have a similar thing for the cosine squared of theta over 2. In this case, we're using this formula. We just basically replace theta with theta divided by 2. And there we get 1 plus cosine of theta divided by 2. And then, taking the square roots again, we get this formula here. So it's almost the same, except you just have to remember where the minus and the plus comes in. Okay. All right, now the tangent again falls under, oh, by the way, the tangent squared. It's probably best to just realize the tangent is sine over cosine, so tangent squared is sine squared over cosine squared. So we can just substitute these two expressions in, and the 2's cancel, and we get 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. And then replacing, for the tangent of theta over 2, this is the sine of theta over 2 over cosine of theta over 2. And we do a little trick here. We multiply and divide, by 2 sine theta over 2. So that's how we get this expression. And then this sine squared of theta over 2, we know that's equal to 1 minus cosine theta over 2. And 2 sine cosine, that's 2 sine of twice the angle. So these 2's cancel, we get sine theta down here. And then these 2's cancel, and we get 1 minus cosine theta here. And we just note that this is also can be written as sine theta over 1 plus cosine theta, because if you cross multiply, you get 1 plus cosine, 1 minus cosine. You multiply these, this is equal to sine squared. And we know this is true because if you multiply this together, you get 1 minus cosine squared, which we know is sine squared. Okay, so the good news is you won't have to prove any of these formulas, but you should know how these formulas come about. Okay, and I'm glad that we are doing this on a video, whereas before we would have to spend 30 minutes writing all this stuff on a chalkboard. Okay. Now the important thing is, okay, how do we apply these formulas? Okay, so let's do that. So we'll keep these formulas nearby if we need it. And let's do some examples. Okay. So the cosine of 15 degrees. We actually did this in the previous section using the sum and difference formulas, but now we're going to do it using the sum and the double angle and half angle formulas. And we probably want to use the half angle formulas because we can see that 15 is 1/2 of 30. Okay, so that is, and we know what the trig values of 30 are, right? So this is going to be, according to the formulas that we did, is square root plus or minus the square root of 1 plus the cosine of 30 degrees divided by 2. And do we have a plus or a minus here? Well, what quadrant is 15 degrees? 15 degrees is in the first quadrant. So everything is all the trig values are positive in the first quadrant, so this is the positive square root. And so we just have to remember that the cosine of 30 degrees is square root 3 over 2. And we could leave it like this, but I'm going to somewhat rationalize things. I'm just going to multiply and divide by 2 over 2. And this will be, then this becomes 2 plus the square root of 3 over 4. Could leave it like this, or we could write this as the square root of 2 plus square root of 3 divided by the square root of 4, but the square root of 4 is 2. Okay. And so we have that. Square root of 2 plus square root of 3, all divided by 2. Now, in the previous video, we did this, we got a different form for it. Okay. We actually found that the value was the square root of 6 plus the square root of 2 all over 4. Okay. But I will just say that if you take this number and square it, you do get 2 plus square root 3 over 4. Okay, just if you have them, if you're not convinced, you can just do it. So some of these numbers have different forms. Okay, they can both be correct. All right, let's look at the next examples. Cosine of 165 degrees. Okay, now what should we use here? Well, 165 is half of 330 degrees. Okay. Now, well, wait a minute. What's 300 degrees? Is that one of our well-known angles? And actually it is. Okay, because 330 degrees is in the fourth quadrant, right? And 330, that's basically the same as negative 30, right? Okay, and we know that the coordinates of this, if this is negative 30 degrees, coordinates are square root 3 over 2, a negative 1/2, right? So the cosine of 300 degrees, of 330 degrees rather, so I said this is the same as 330 degrees. And so that's why we kind of need this. I'm going to stay away from the radians for now, but that's what this is. So this is going to be, now, 165, however, this is in the second quadrant. Okay. And so the cosine is going to be negative there. So that's why we have we'll use the minus, and then we'll have 1 plus the cosine of 330 degrees over 2. And this will be minus the square root of 1 plus square root 3 over 2 over 2. And you can see that that's basically going to be the opposite of what we had up here. So I'll just cut to the chase and say this is equal to negative square root of 2 plus the square root of 3 over 2. You can skip some steps. You can fill these in if you want. All right, let's look at the next one. Now we're going into radians now. Cosine of 7 pi over 8. Okay, keep this in mind. This is in the second quadrant. Okay, so the sine will be positive. The cosine will be negative. And this is half of 7 pi over 4. Now, 7 pi over 4, that is one of the angles that we know about, that we're required to memorize, right, or be familiar with. 7 pi over 4 is down here in the fourth quadrant, right? Okay, and of course the sine and cosine of that would be, the cosine would be square root 2 over 2, and the sine is negative square root 2 over 2, right? Okay, so so now this is going to be the sine, we're in the second quadrant, this will be positive. Okay, so this will be 1 minus the cosine of 7 pi over 4 over 2. And then this is going to be, then the minus comes from the fact that we're taking sine of half an angle, using that angle. And so this will be the square root of 1 minus square root 2 over 2 over 2. And we can rationalize things by multiplying and dividing by 2. Not rationalizing, but simplifying it. And this will be the square root of 2 minus square root 2 over 4. Okay. Okay, or you can say this is square root of 2 minus square root 2 over square root of 4, which is 2. Okay. So you can do it that way. Next, the tangent of 9 pi over 8. I think hopefully you kind of see we want to do the half thing. And half of this is 9 pi divided by 4. And that is another angle we should be kind of familiar with. Okay, because 9 pi over 4, that's 2 pi plus pi over 4, so it's in the first quadrant. 9 pi over 4 is basically the sine and cosine are the same as for pi over 4, so we have root 2 over 2, root 2 over 2. Okay, so that's a sine and cosine. So let's do this. So this will be 1 minus cosine of 9 pi over 4 divided by the sine of 9 pi over 4. And so this will be 1 minus square root 2 over 2 over square root 2 over 2. And we can, if we multiply and divide by 2, this is going to be 2 minus square root 2 over square root 2. And let's probably rationalize this just for good measure. And now we get 2 square root 2 minus 2 over 2. I guess which simplifies to square root 2 minus 1. Okay, I guess that's what it is. I did it wrong on my notes, but okay, if we did everything correctly. Okay. Let's go to the next sheet. Example number 5. Okay, the cosine of theta is given in this case. It's negative 1/6, and now we want to find the we're given that theta is in the second quadrant because it's in between pi over 2 and pi, and we're asked to, let's try to find all 6 of these quantities that we're asking. It would be helpful to know what the sine of theta is first. So this was going to be square root of 1 minus cosine squared of theta. Because we're in the second quadrant from here, and we know the sine is positive here, so this is just going to be a positive square root of 1 minus cosine squared. So this will be 1 minus negative 1/6 squared. So this will be the square root of 1 minus 1 over 36, which is a square root of 35 over 36, which is the square root of 35 divided by the square root of 36, which is 6. Okay. So that's the value of sine. Okay. So once we have that, the rest of it is a little easier. The sine of theta, or the sine of 2 theta, then is going to be 2 times the sine times the cosine and this is going to be negative square root 35 over 18 after you simplify things. Okay. The cosine of 2 theta. We can do this a number of ways, but probably the easiest way is to write this as the cosine squared of theta minus the sine squared of theta. So this will be negative 1/6 squared minus negative square root 35 over 18 squared. Okay, and then this will be 1 over 36 minus 35. Actually, this should be a 6, not an 18. I was thinking about this. Okay, so this will be 35 over 36, which will be negative 34 over 36. And if we want to reduce, this will be negative 17 over 18. Okay, the tangent of theta, or the tangent of 2 theta, we can use the formula, or we can just, I've already computed the sine and the cosine, so let's just divide these. And this will be negative square root 35 over 18 divided by negative 17 over 18. The 18s cancel, the minus signs cancel, and so this is just going to be the square root of 35 over 17. Okay. So you don't necessarily have to use a formula to do this. Certainly, if you have the sine and if you have the cosine, just divide them and be done with it. Let's say if we want, what would be, by the way, we can see that the 2 theta, it turns out to be in the third quadrant because the sine and cosine are both negative there. Let's look at the cosine of theta divided by 2. Okay. Let's first of all figure out what quadrant we're in. Because the quadrant is, theta is between pi over 2 and pi, we can divide everything by 2. And we'll get that theta over 2 is between pi over 4 and pi over 2. So that means that this is, so theta over 2 is in first quadrant. Okay, so that means that all these square roots will have to be the positive square roots. So this is going to be a positive square root of 1 plus the cosine of theta over 2, which is the square root of 1 plus negative 1/6 over 2, which is the square root of 5/6 divided by 2, which is the square root of 5/12. Okay, we'll just leave it like that. And the sine of theta over 2 will be the positive square root of 1 minus cosine of theta over 2. This is the square root of 1 minus 1/6 over 2. The minuses cancel out and we get 1 plus 1/6, that's 7/6. So the answer will be square root of 11, square root of 7 divided by 12. And then for the tangent, let's just divide stuff. So the tangent of theta over 2 is this divided by this, which can be written as square root of 7 over square root of 12 times the reciprocal of this. So this will be the square root of 7 over square root of 5, or the square root of 7/5. Okay. Now I should say, if you wanted to do it the other way, and use the formula, you could also write 1 minus negative 1/6 over square root of 35/6. If you did use the actual formula, we could get this, but this actually reduces to the same thing. This is going to be 7/6 over square root of 35/6. which is 7 over square root of 35. And, well, it looks like it's different, but actually 7 can be written as the square root of 7 times itself, and the square root of 35 can be written as the square root of 7 times the square root of 5, and the square roots of 7 cancel out, so we get the same thing here. So you can use the formula, but you'll just get a different form. Okay. Still the right answer. Okay, let's take a break, and then we'll continue with these examples on the next video.